So let's start. We actually don't have a microphone, so I'll speak a bit louder. My name is Anton Pleshivtsev. I'm from Virool. Virool is a social video marketing platform which shows video advertising all in internet. And my speech is about video player based on modern technologies, HTML5, CSS, JavaScript, which is replacement for the default mobile player, which is included in iOS devices and Android devices. So why did we decide to create a custom player? Actually, there were two main reasons here. And first reason is inline mode. If you know the default behavior for the iOS video player is full screen mode. So if you switch on the video stream in the web, you got it opened the full screen mode, so you cannot continue reading. And the second thing is autoplay. By default, iOS devices require some user interaction, like click or scroll, to start video playback, and we wanted it to start its playback automatically. So our first try was quite simple. It was based on just image tag, which contains source image. We were changing this source with some timeout, say 100 milliseconds, and we were using an audio tag. And this solution works great, but it has one pitfall: a lot of network requests. Say for 5 minutes of video, we have to make 500 requests, and this creates a lot of load into users' bandwidth, and it eats a lot of traffic. So we had to do something with these requests, and we decided to use just sprites. We call it batches, containing say 10 frames in one batch. So we can load this sprite, and we have 10 frames of video. And if we use 100 milliseconds timeout between frames, so we have 1 second of video loading this sprite. And this is how it works. We just load the frames, and we switch them using the background position. So we can show the second frame, third frame, and so on. And we actually got simple movie. This solution works great, but we finally faced a shaking video problem. This is because of resizing player for different screen sizes. It shakes like like old movie. The problem is with background position, which is not very exact in pixels. In some percents, it becomes not very straight, and it shakes. So we had to find some solution to avoid these shakes, and the solution is using Canvas API. Canvas API helps us to crop the image dynamically, so we can load image sprite containing 10 frames and crop the current frame every 100 milliseconds. So this is just simple function call which helps us to crop the frame and to show it. So we load 10 frames, crop first, show first. This is how it works. We load a batch of frames containing 10 frames of video, we crop it, and we just put it into image source, and we show the frame. This method helps us to avoid any shakes, any network problems, and this works pretty well. But there are a lot of another pitfalls on iOS devices and also for Android devices. Say audio problems. We cannot switch audio automatically on these devices, and Also, there are huge problems with synchronization of audio and video streams. The first try was to use an audio tag, HTML5 audio API, which seems to be a pretty good solution for this task, but it has some strange troubles. Say on 5th second of audio playback, it suddenly becomes in buffering state, so we have to stop video to wait the audio to load some more audio seconds and to start playback again. This is not quite simple to synchronize audio and video streams, so we had to find some solution that we have that help us to load the whole audio stream into memory and to switch it on at one time. And here is the coding technology. It's called Audio API. This is absolutely different from audio tag, and this allows us even to add some audio effects, say echo or something like that. So we can switch on the audio when we have 100% loaded of audio file. And the main problem after using this API is correction of our video and audio streams. So this is how it works. This is how we expect it to work. We show the first frame, we just use 100 milliseconds timeout for the second frame, then we show the second frame, and so on. First problem is we cannot just use set interval for this task. There is a main idea just never to use set interval in JavaScript, and for sure we can solve this problem using just set timeout method, but the actual implementation works like this. So rendering one video frame takes some time. So when we show just 8 frames of the video, our second passes, and our audio track doesn't stop, so it becomes desynchronized, and we hear some lagging here, and we have to do something with the problem. And the solution is quite simple: is to use the global watch to measure time of frame rendering. So we check the beginning of frame render time, then we render it, and we check the end time. It's like dynamic benchmarking, you know. When we know the time of the frame rendering, we can use the 100 milliseconds timeout and use just not 100 but 100 minus frame time. So in the following example, it's like 78 milliseconds, and everything goes fine using this approach. Video and audio streams don't become desynchronized. And the next problem here is timers. When we use JavaScript timers and we switch tabs, they just stop. We cannot run timers in inactive tabs, and there is no just simple solution for this, but one solution that is good enough is to use WEBWORKERS. WEBWORKERS helps us to run these timers in different threads, so we can switch tabs, we can even switch apps, and our timers don't stop, and we can just show the video on the background, and this helps us to avoid some terrible desynchronization of audio and video streams, and to run our timers in inactive tabs. This is how it works, but WEBWORKERS solution contain a lot of small pitfalls also, and the main problem here is it cannot be run from the same file. We should always run worker as a separate JavaScript file. Solution here is first, sure, using a separate file, and the second solution is to run just a special object, like blob objects, which helps us to simulate different files using our string. So in this example, we just create like separate file using function toString method, and this function contains all logic of running our timers and sending the events from them back to the main page when they were started. So this API helps us to run just like timers and everything. So speaking about cover player, it's written completely in pure JavaScript. It's about 5 kilobytes total. It's been tested on iOS devices starting from 3rd version. It's been tested on Android devices. It uses very simple browser methods and just very simple solution that works everywhere. It can start video without any user interaction, showing this video just in text like it was like banner, and it doesn't require any video formats. The main difference here is we use special converter to just take say AV file and to create these batches containing 10 frames to preview this video in our player. So this player requires to have just special software to convert them to its own format. So thank you. This is pretty much it. This is a quick description of our player and its technologies, APIs, and if you have any questions, I'm glad to answer. Yep.
So in terms of like performance, how did you benchmark the performance of the player?
I actually used standard Chrome tools to check what function calls was the most expensive, and the most expensive was actually the canvas rendering method. It's easy to understand just because of it takes a lot of image data into memory, and it takes a lot of time to render this data into canvas. So you have to do everything to make it faster. I think the most simple solution here is to use the optimized images containing not much just image data here. And the second just like tool for benchmarking is simple measuring function calls, just like using global watch to measure when it starts and when it finishes. That's it. Yep.
Did you ever try running the video at more than 10 frames a second? Was that a limitation that you had?
Yeah, we tried first. It was about 20 or 30 frames per second, but we have to find a good solution between speed of video loading and performance in users' browsers. And if we take much than 15 frames per second, some older devices can just act not so fast. They can video becomes like chunky. We can face different problems with performance. This is a problem of mobile devices memory. Memory of browsers, of mobile browsers, like smaller than the whole device's memory. There are about maybe 5 megabytes or something like that. So we really have to make everything optimized. Even audio track here becomes mono channel. It becomes very low quality just to require as as little memory as possible. So the actual answer is yes, we tried different frames per second, but we found the 10 is the most suitable. Frankly speaking, we have checked another solutions. There are, if you know, any Vue player, and there are famous Cope player for showing video in mobile devices, and they actually use 10 frames per second rate.
Thank you.
What was that other player you just mentioned?
Sorry?
You said the other player that also uses 10 frames per second. What was the name of that?
The first told is AnyView. It's like startup creating the mobile player. And the second is Cope. I'm not sure if you know, this is a quite popular service showing short videos like YouTube, but only limited to 10 seconds. They also created the same technology, and I know the guys who founded the company, and they found a different solution to synchronize video and audio streams. They actually use default audio tag solution, and they catch on-time events from this tag. So when the audio says it's 1 second, they change video frames. When audio says it's 2 seconds, we change video frames. So they synchronize video depending on audio, and we synchronize audio depending on video. This is a difference. Yep.
From switching from mobile to desktop, do you use the same player, or do you do device detection and use a different?
Actually, we want to show a better quality videos on desktop devices. So we do device detection, and we show the full size videos, not just from cover player. And for mobile devices, cover player is used. So that's it from my side.